Good morning everyone, and welcome to today's worked exam answer video. Today I'm having a look at something which could come up as a year 12 question if you've got upcoming end of year exams, for example, or of course could come up in the A-level papers which are happening next month. So we're having a think about shapes of molecules and ions, and within this question there's quite a few things that they want us to do, and when you get a list like this, perhaps not necessary in this question because of the way they've then laid out the space for you to work in, but in other questions when you do have a bit of a list of things that you need to do, it might be worth just ticking them off as we go along. So we're thinking about shapes of molecules and ions. We have to draw the shape of NCl3 and NCl4+. We have to include any lone pairs of electrons that influence the shape. Then we have to name the shape of the NCl3 and then state and explain the bond angle in the NCl4+. And like I say, they have broken that down nicely in this question, which I'm pretty sure comes from an AS paper, but in other types of questions, in other papers, there might be a list of things you need to do and they may not lay out the space you have to answer the question in such a nice way. So a bit of a tick list might be useful. So let's have a think first of all about the NCl3 and everything that we have to do with that. So we have to draw the shape of the NCl3. If there are any lone pairs, we've got to make sure we draw those. Then we have to name the shape of the NCl3. We don't need to think about bond angles, but while we're here, I might as well. So when it comes to working out shapes, there's kind of two things. One, we need to be able to work out how many lone pairs and how many bonding pairs there are. And then secondly, once we've worked that out, we need to remember the name and bond angle of the shapes that have that number of bonding pairs and lone pairs. So the way in which I do this is I will find what group nitrogen is in, because nitrogen is going to be my central atom. So because nitrogen is in group 5, it's going to have 5 electrons in its outer shell that it can use in covalent bonds with whatever it's bonded to, in this case chlorine. Now, because there are 3 nitrogen to chlorine bonds, nitrogen will use 1 electron in each of those bonds, meaning it's going to be using a total of 3 electrons. And if it has 5 and it's only using 3, then we're going to have 2 electrons that will be left over, if you will, that are not going to be used in bonds. And that gives us an indication of how many lone pairs there will be. So 5 electrons in total, 3 being used, 2 left over. Obviously we're thinking about pairs, so 2 electrons makes 1 pair, so there will be 1 lone pair of electrons within this shape. And then because the nitrogen's bonded to 3 chlorines, there will be 3 bonding pairs. So that's the first thing that we have to do, and then from there we need to know that any shape that has 3 bonding pairs and 1 lone pair is pyramidal. So that's the name of the shape. And then we also need to be able to draw it. So a pyramidal shape is based on a tetrahedral shape, but where one of the bonding pairs would be in a tetrahedral shape, it's replaced by the lone pair. Now it doesn't matter which position you put the lone pair in, but convention is that we tend to put it in this upper position. So that's my lone pair, and then I'm drawing the little semicircle to show that that's in a little orbital. And then I've got my 3 bonding pairs. So one is going to be in the plane of the paper, and then we're going to have 1 coming out of the plane of the paper towards us with the wedge, and then 1 going back into the paper with my little dashes. And you do need to show 3D when you're drawing shapes if it's relevant to do so. You don't need to do 3D for linear, and you don't need to do 3D for trigonal planar, but anytime there is a 3D shape, we do need to use the wedges and the dashes. And I've got my lone pair on there, so I've drawn that shape, I've included any lone pairs of electrons, and I've named the shape pyramidal. Okay, so that should be everything that I need to do for the NCl3. But a little bit extra in terms of the bond angle here, it won't be the same as the bond angle in a tetrahedral shape because lone pairs repel bonding pairs more than bonding pairs repel each other. So what this lone pair will be doing is squidging these three bonding pairs ever so slightly closer together than they would be pushing each other in a tetrahedral shape. So when we have one lone pair, the bond angle goes down by 2.5 degrees. So it's not required here, but for context, the bond angle in a pyramidal shape is 107 degrees because lone pair to bonding pair repulsion is stronger than bonding pair to bonding pair repulsion. That will come up in other questions and you may have to explain that, and you have to say about the strength of the different repulsions. Okay, now for the second part we have to draw the shape of the NCl4+, again include any lone pairs of electrons that influence that shape. We don't need to name this shape, but we do need to state and explain the bond angle, which is given us space to do down here. So again, figuring out the shape, first of all, I'm still going to look at nitrogen because it's still my central atom, still in group 5, so we've still got 5 electrons to play with. However, the positive charge on this ion means that the nitrogen doesn't actually have 5 electrons. It is positively charged, so that would suggest it's lost an electron. So the positive charge actually loses us an electron. So we only have, in the first place, 4 electrons that can be used in bonding pairs. Then we can have a think about how many atoms the nitrogen is bonded to, and it's chlorine again, but this time we have 4 nitrogen to chlorine bonds, and nitrogen will use 1 electron in each of those bonds, so a total of 4 electrons will be used, and that means that there will be no electrons left over, and that tells me that there are going to be no lone pairs because there's no electrons that are not being used in these bonds, and we have 4 chlorines bonded to the nitrogen, so there are 4 bonding pairs. So this would be tetrahedral, not that we need to say that for this question, but you may obviously in others. So once you've worked this out, it's a case again of knowing 4 bonding pairs and no lone pairs equals tetrahedral as a shape. Now that's therefore going to look really similar to the pyramidal one, except where the lone pair is in our pyramidal shape, we will have a bond to the Cl, and then all of the other bonds will be the same. Like that. And then because this is an ion, we need to make sure that we pop the shape into square brackets so that we can then put the charge on the ion outside like that. So because this is a regular tetrahedral shape, in terms of bond angle, again we need to know what the bond angle is, so it doesn't matter between which 2 bonding pairs, all of them will be separated by an angle of 109.5 degrees. And I could have drawn that there, or there, or there, or there, or between this one and this one, or this one and this one, and it would always be 109.5, which I do need to specify down here. And then we need to think about why. So the explanation of the bond angle here isn't relevant, or we don't need to talk about the lone pairs. The lone pairs aren't relevant, obviously, because there are none. So why, if we have 4 bonding pairs, do we get this bond angle? Well, all of these bonding pairs want to repel each other by the same amount, and in a tetrahedral shape, this is the furthest we can get them apart, and this is why this is a 3D shape. If we had it in 2 dimensions, sort of like that, no 3D nature, they'd only be 90 degrees apart from each other, the bonding pairs. Whereas actually, if we put them in 3D, we can get them further apart, and they don't want to be close together because, of course, electrons are all negatively charged, so they're going to repel each other. So in terms of explaining this bond angle, we would say that the bonding pairs of electrons repel one another equally, so they are positioned as far apart as possible. So when we're thinking about electron pair repulsion theory, the bonding pairs will repel each other equally. As soon as we bring in a lone pair, the lone pair to bonding pair repulsion is then stronger than bonding pair to bonding pair repulsion. And if we have shapes with two lone pairs, such as V-shaped, which is two bonding pairs and two lone pairs, the lone pairs will repel each other the most. Then the lone pair to bonding pair repulsion will be the second strongest, and again bonding pair to bonding pair repulsion will be the weakest of those three. And that's what we often need to explain when it comes to bond angles. So if you've got all bonding pairs, the bonding pairs of electrons will repel one another equally so that they get as far apart as possible. If we've got lone pairs, it's a case of saying, well, actually the lone pair will then repel the bonding pairs more, and so the bonding pairs get closer together and that bond angle decreases. Hopefully that's all made sense and has been a little bit of use to some of you. Any queries, as always, please let me know in the comments or drop me a message, email, whatever works for you. And any further shapes of molecules videos you'd like me to have a look at, please let me know, and wish you all the best with the rest of your revision. Thanks for watching, guys.